Hi, welcome to this session. In this session, we will talk about the very hot topic about deep learning. And very challenging issue is how to deploy and train a model using Tensorflow or other libraries in the Yarn environment. And what we propose, the ideas and the solutions, is very easy to use. This should be make the data scientists and machine learning engineers very comfortable. My name is Yan Bo, and this is Wang Da. We both work at DataWorks, and I'm a machine learning engineer, and he is working on system and infrastructure. So I think most of companies has two parts of gas. One part for machine learning, and another for the system. So they will meet the similar issues like we will talk about. So like talk about how to face the challenge and how to resolve it. So first I will talk about with the machine learning Hive, what's the requirement and what challenge for us to train some models. And then Wang Da will talk about the system support and how it works. Okay. Here I listed a lot of machine learning problems like CTR prediction, recommendation, very traditional problem, and like natural language processing, like image video recognition and personal assistance is very very hot topics recently years because the deep learning. Like ImageNet has got a great achievement since the deep neural network has been proposed. So for the traditional machine learning problems, for the traditional machine learning problems, we will say use like lab linear, use lab FM, use sklearn. It can be solved very, very well now. And for recently, like SD-Boost and Spark MLab provide some distributed and maybe single node solutions for non-deep learning problems. They can solve them very well now. And actually, these kinds of libraries can run on Yarn platform very well now. But the deep learning libraries like TensorFlow and PyTorch or MSNet, how we can use it on a distributed platform very, very easy. And how we can use it to improve the working efficiency of data scientists of machine learning. Yarn provided a solution for us. So let's talk about what will make the machine learning engineer comfortable and what will make them uncomfortable. For machine learning engineers, they may be very, very familiar, like linear algebra, like the machine learning algorithm. We're familiar with learning rate. How to change learning rate to make your model converge more fast. We're familiar with Python. So we should, like the machine learning engineers, do the things that they like. And some issues like resource management, OOM, some error. For example, we read a file and like some authorized issue, we can't have authorized to read it. And the networking error, maybe your network port is binding to other applications. We don't want to handle it. If my boss told me, you need to handle it, then I will talk with us. And then I will talk with us, I want to quit this job. I want to move to other companies. So the problem is here, and what can make machine learning engineer working more efficient? We should provide a better platform. So let's walk through the machine learning work, ordinary machine learning work every day, and say what's the machine learning engineer's requirement. And then we show a demo how Yarn can satisfy this requirement. First thing is where we will store the training and test data. I think in a lot of companies has many machine learning teams, and in each team has many persons. Maybe they do similar works or not similar works, but the data they should be used maybe the same data. So a better way is using a storage system. We can save all the data on a shared storage, and everyone in the team can access it. So HDFS or S3 provide us a solution. It can share data between the team members because every person in the team members want to access the data and use them to train some models. Even for the same problems in a machine learning team, maybe different sub-teams will use different ways. For example, one way use some linear models, other teams use some neural network models, and another team use like XGBoost, some tree-based models. And at the end, maybe we will ensemble these models together for the final model and do model sharing or prediction. So the data sharing is very, very important. And another thing is from the data from the ingestion into the HDFS or S3 to the actually machine learning training, it will do some pre-processing. Like we will do some data augmentation or some remove some invalid value or something like that. So usually the data set is very, very big. So the distributed computing framework like MapReduce or Spark can help us. So we should have a platform can integrate this framework together. And if we have a data for a machine learning engineer, we want to do experiment. What is experiment? Experiment usually happens on not full data set. Because usually your full data set is very, very big. Experiments means you will train many models and choose the best models, like the hyperparameter tuning or cross-validation. So in these steps, each team members will use like single node CPUs or single node GPUs to train the deep learning models. And the data set for the models may be not so big, but they should be simple from the full data set. So this is one of the requirements to the infrastructure. And then after we have designed a good neural network architecture, we have designed a very good hyperparameters, we get the best models. And then we will push the best parameters and the neural network architectures into the full data set. Then we will get the final model. This is the next step, maybe a very important step. Since this step, we will get the models you will use to prediction or sharing. So after we get the model, so usually these steps, the data set will be very big. You can't train on single node. You should train on distributed. So after we have the final models, what we want to do is push the model to sharing. So this is the whole workflow of the machine learning engineer. I will face the same workflow every day. So if we can have a good system which can facilitate us for this work, it can make us work very efficiently and can make us work very happily. So what's the most important thing in the whole steps that doesn't sold very well now is we will train models from single node CPU to single node GPU to multi-node CPUs and GPUs. Because every machine learning engineers will face these situations or this requirement, and they will train models in the different ways. So Apache Yarn provides us a service on Yarn, which is a TensorFlow service. Because currently there has some in progress in the Apache Yarn community that Wang and his team has worked on to make TensorFlow as the first class citizen in Yarn. So next, let's show a demo to show how it's very, very easy to use to train all kinds of deep learning models on Yarn. Okay.
Yeah, this doesn't work.
Wait for a second. We have some mistake at the demo. Wait for a second.
Yeah. Yeah, my mouse cannot move to the right.
Okay, let's show the demos. First, we need to find the data. This is the Ambari UI. We can check the data on HDFS. We can use HDFS console command, but we can also use the HDF file browser on Ambari. You can say this is the file system, the files on HDFS. We will store the training data here. This is the TensorFlow TF record format data, and the data size is not so big. You can use more big data because Yarn can handle it. This is only for demo. And then we will try to find models that are written by machine learning engineers. Currently, we use the model is a download from Google TensorFlow models repo. You can say these models. Actually, this model is done from Google TensorFlow models. You can write your own models in your dataset of machine learning teams. And for machine learning engineers or data science, it's very, very comfortable to write some Python code to build the models. So in the Python script, that's the best suit for the machine learning engineers. So what makes them uncomfortable is after they write the code, they want to deploy them in single node and in multi-node very easily. So let's say, suppose we have the data, the script, the machine learning models. It's a Python file, and then we want to run it on Yarn. You can say the following command is the most important command we will show in the demo. That's how you run TensorFlow on Yarn. You can say the command. Oh, sorry. You can say the command is run TensorFlow. This will be supported in the later Yarn release. It will, because in the later Yarn release, TensorFlow will be the first class citizen in Yarn. So this is the built-in command in Yarn in the later release. And what we should do is to write a spec file. -- input spec. The file is we want to write. We will show it how to write it later. And then we use a Docker image. Because Docker image can help us to solve the dependency-related issues. For data scientists, it is very, very uncomfortable to handle too much system dependency-related issues for the GPU configuration or NVIDIA driver issues. And actually, this work can be shared in a whole team. So we can provide some Docker image. And actually, in the Yarn 3, more than Yarn 3, we can support it run Docker. So we have this command. Let's show how to write a spec. The spec is very, very easy to write. It's just a JSON file. We will specify the different rows in TensorFlow by the spec. You can see the spec. There are 4 rows in our demos. The first row is the master in distributed TensorFlow. The second is the worker. And the third is parameter servers, PS. And the last one is the TensorBot. Because we want to track the training process during the model training. And we can specify CPUs, memories, and GPUs for each rows. And then we write the launch command. The launch command should be familiar with machine learning engineers because even they write a single node TensorFlow job, they will use it. So this should be easiest for machine learning engineers to write. And after they have this, they can submit a TensorFlow job on Yarn, even from single node to multiple node. In my demo, we have 4 rows. We will check the 4 rows as the yarn UI later. Let's first submit the job. We use this command to submit the job to the yarn cluster, and then the job starts running. And then we went to the yarn UI, or to the UI, to say what's the status of the cluster. First we can check whether we have GPUs. You can say at the bottom right, we have 6 GPUs on the cluster, and 4 is used and 2 is available. Because in my jobs, I specify 2 GPUs for my jobs. And after that, we click the servers tab, because now yarn is as a service on yarn. Now TensorFlow is a service on yarn. Then click our jobs, because we specify the job name as distributed-tf. So we click the job name. Now you can see the 4 rows is showed in the UI. The master, the PS, TensorBoard, and the workers. And each of the resource for each of the job is showed also in the UI. So you can check it's right, or whether it's satisfy your requirement. You have some typos or not. And at this UI, you can also check some logs and some configuration metrics in the same UI. Because for machine learning engineers, some of the information will be printed or logged into a file when you train the models. So logs should be one of the ways for you to diagnose or to tuning the job. So we can show the jobs. And then we can click the TensorBoard link. The job is running on the yarn cluster. Machine learning don't need to care about where it runs. We just need to click the link. We can show the TensorBoard. The TensorBoard is for our models. We are very familiar with the TensorFlow graph and the operations of the tensors on the graph. You can to check or to diagnose your models in the UI, in the TensorBoard UI. And all the elements or the stuffs on TensorBoard can be showed here. Like we can show the projector. If you train like a word-to-vector model, you can show the very visualize the picture of your models of word-to-vector. And we also can check the learning rate change and the loss change. This is very, very important to machine learning engineers. Because if you found your model is not converged very well, you need to change the learning rate scheduling, or maybe you need to change some parameters. So the TensorBoard provides us the facility. And the machine learning engineer use this way for the TensorBoard is the same way as they train a model in single node. So we can say the loss and the global step change and the accuracy change for the models. So this is, we have started to train the model. Then we try to find where the model stopped. That's directly we specified as a spec file. You can say there are events file for the TensorBoard, and we can show also the model checkpoint. After we have finished the training, we can push the model for serving. So you just need to care about the stuffs in the folder, because this is what you got for the model training. Okay, so we have finished the demo. You can say the demo is really, really very, very easy for data scientists or machine learning engineers. We just need to write a spec file. It's a JSON file. Very easy. And we need to specify the CPUs, GPUs, and memories, and the roles for each component in our TensorFlow job. But actually, there are a lot of issues need to solve to make this run very smoothly, very simple for machine learning engineers. This is Wang Da and his team has did very good work for the yarn, make this happen. So Wang Da will talk about the details.
Yeah, so that sounds simple. Actually, this is too loud. Yeah, so with my infra hat, this doesn't work. Sorry. Yeah, so for things to do, so Yanbo just talked about everything needs to be very easy to use. But what actually Yanbo saying is, it is just the tip of the iceberg. What we say is to make the things to run very easy, you have to do a lot of works. So there are several important things we need to do to make the machine learning engineer life easier, such as packaging and dependencies. And we need to care about the GPU isolation. We don't want the machine learning engineer to understand what's the GPUs under their job and how we do the isolation. And we want to make sure everybody can easily access the shared file system, such as HDFS. That means we need to make sure everybody can access the curverized HDFS in an enterprise. And also, we need to make them kind of easier tracking their job. They want to see what's the state of their job and go to the history of their job loading, etc. And the last but not the least is we want to easy to deploy machine learning jobs. So what I'm going to talk is I want to share what the yarn side to do to support all these things. So first, let's look at from the workflow which Yanbo shared, how we do the machine learning experiment on yarn. So first, we want to do some sampling and pre-process the data from HDFS or S3. So there are many applications which can perfectly running on yarn can handle this, such as Hive and Spark. They don't need to do much things to make them work. And also, there are many data scientists in a company don't have very high-end GPUs on their laptop. So I think most of the laptop don't have very high-end GPUs. So when they want to do experiment, they want to have some environment to do that. So let's see how they can do that. So basically, the solution is we can ask the machine learning engineers to just pat their dependencies to a Docker image, and we can launch a notebook to make them work. So just like what I shared in the keynote today. So let's look at the steps we needed. First is pat the dependencies. So if the machine learning don't know about much thing about the Docker, they can have some common Docker image created by the infra team to do this. It's not hard. And also, they need to specify how much resource they needed, including memory, CPU, and GPU, and maybe some other stuffs. And also, they can run the notebook service on yarn. So it seems there's no answer here, huh? Okay, it's okay. So basically, what we the machine learning engineer needs to write a spec like this. First is to specify the artifact of the Docker file name, the Docker image name, and what's the launch command, and what's the resource needed. For here, they asked 4 CPU and 16 GB memory and 2 GPUs. So with all of this, here is the place we can create the services on yarn. So. But this resolution is bad. So basically, we can click one click, and we can deploy this Zeppelin notebook on yarn. Very simple. And once the machine learning have the notebook and develop their model and make the model works and tune some parameters, they want to deploy the model to the model training to the production. So with this, we can make the training task to submit to yarn using the submit TensorFlow .py, which is part of the yarn to submit the TensorFlow job to yarn. With the input spec and the Docker file specified, this training can run on yarn. And here is a sample of the spec file. So I think Yanbo already covered many of this, so I can make this talk faster. So basically, they can have so here is the spec file for the single node TensorFlow training. And we have the worker specified here, and the resource is CPU, memory, and GPUs. And for the launch command, they will specify the Python file name. This is for the Cypher 10 training, and where the data is. So this is on the HDFS. And where is the job directory, which stores the training snapshot, so they can take it to the prediction, or they can recover from this location. And the training steps is how many steps we needed, and there are some other command for the some other parameters for the tuning to make the training to be more accurate and faster. And they can specify number of GPUs here to tell TensorFlow how many GPU to use. So once this is submitted, this can get to the yarn. And what if the user wants to have the distributed TensorFlow? So it's very easy. Just add the parameter server master component to this spec, and the yarn will generate the TF config environment. So this can automatically run in distributed model without many engineers' work. So after the model training, we going to deploy this model to the online prediction. So here's a spec to deploy the online prediction. So this will use the Docker image, and it will run the command to do the simple TensorFlow serving, and specify number of containers to 10. So in the backend, we can do the load balancing. So and once this is deployed, yarn will generate a DNS entry for this serving service. That's the serving job name and domain name port, to make the other services can easier access this serving service. So this is a so I'm going to talk about the recent words to support the machine learning workflows like TensorFlow. So first is how we do the GPU isolation and scheduling support, and second is the native service, which can help us to deploy the services from any custom services. All this is available in Apache Hadoop 3.1, and this is also part of the HTTP 3.0 early access bits. And for the Apache Hadoop 3.1.1, which we going to working on, we will include many enhancement and the stabilization words as well. So this is the GPU support on yarn. So basically, the first question is why need isolation? Because for many machines, they have multiple GPU cards. And for many of the applications, they only need a few of them. They don't need all these GPU cards. So if we have allocated several processes to use a single GPU device, this will cause the access to the GPU to be serialized and will easily cause the out-of-memory issue. And NVIDIA don't have provide a way to isolate multiple access to a single GPU. So with this, what we're going to do is when user asks GPU, the yarn will put these containers to different C groups. So every container can see its own GPU, and they cannot do jailbreak after this. And for the Docker, it's same. So we will pass the -- device to tell the Docker to isolate the GPU usage of the launched process. And for the Docker plus GPU support, as Yenbo mentioned, many of the machine learning need some different dependencies. So Docker is the best way to solve the packaging issue. But to directly support the Docker GPU isolation, if the user build the GPU-based libraries inside the Docker container, this won't be portable. So if the host OS driver version conflict to the inside the Docker image, if the driver and the Docker image GPU libraries have any conflict, the container will fail. So instead, we'll use the NVIDIA Docker plugin to automatically mount the NVIDIA drivers when the container gets launched. So this can solve the problem. So finally, we can, after all these features, we can make our life easier as an infra engineer. So let's say we have a cluster running some existing Yarn jobs like the TADS, Spark, and LLAP for Hive for the interactive query. And if the machine learning engineer wants to have the GPU workload, we can add them to the same cluster. And we can run in TensorFlow, Caffe, and MSNet on this platform without any modifications. So there are some advanced features of the work. First is we support the Kerberos HDFS access to make because the original TensorFlow supports the access HDFS without any issue, but the process is pretty hard. They have to run several Hadoop commands and to properly set up the class paths and Kerberos tokens to get the access. But under Yarn, we want to make this to be easier. So because Yarn already automatically generates the delegation token for the HDFS access, so for our work, we will automatically run some pre-set up steps to make the HDFS class paths, etc., properly pass to the TensorFlow to make the TensorFlow can access. And also for the native service, the user can provide the Kerberos principles, so the Yarn can know about this. And for the DNS support, as I just mentioned, we will have the we need this to support the distributed TensorFlow because different roles needs to talk to each other. We need to have the pre-established hostname to make them can wire up. And this is also required if we want to have a easier to understanding host names for the TensorBoard or for the survey. Yeah, so just like this. After the TensorFlow job gets launched, there will be a quick link to guide you to the TensorBoard. Yeah, so for the native support TensorFlow on Yarn, this work is available at Yarn 8220. We have the patch available, and thanks the contribution from Sunil and Vinod, and of course Yambo for this work. So any questions? Yeah. Yes. So could you use the microphone to do this? Yeah. Thank you.
Install for this to work, or do you install?
So of course you need to install the GPU driver, and that's the only thing required. And after that, if you want to run using Docker, you need to install Docker, and after that is the whole Hadoop stack.
Whole Hadoop stack.
Yeah. Yeah.
So when you ran the neural net in a distributed mode, so is each epoch running on an individual Docker container, or how is the work distributed?
Oh yeah, so basically when we run the distributed TensorFlow, every task is run on inside their own Docker container, and when because we pre-generate the DNS entries for each task, so with the passed in the generated TF config, they can know how to wire up. They will do this automatically without any users work.
Question actually.
Yeah, go ahead.
So when we run in a single server, right, in the neural network, after each batch, the weights get updated and they are taken as input in the next batch or next epoch. So how is that taken care here? Because
yeah, so basically Yarn will not take care of this. The TensorFlow itself will take care. The TensorFlow runs as is, so we don't expect user to needs to change their code to run on Yarn. They can run the original TensorFlow code on Yarn.
Thank you.
Yeah, thank you.
I have like two questions. It's actually one question. It's mainly due to the fact that so currently when data scientists, let's say they run a model, what they have now, they have direct access to the machine, so they will do things like NVIDIA SMI to check that how much memory is actually getting used, then actually tune the batch size and all these things like that. So just like for here, we Dockerize everything and we hide the machine layer from the data scientists, so because they just submit jobs. So how do you expect this like very common debugging loop to be done?
Yeah, so this is a good question. So basically, inside the Docker container, they isolated many. Since we don't want the Docker container C, but for example, the NVIDIA SMI and some other tools will be mounted into the Docker container, so they can still run the commands to understand what happening inside the Docker container.
Are you suggesting that when the yarn job is running, the user will be able to log into the Docker container and do stuff?
Yes, yes. So basically, this depends on how you build the Docker image. So if you build the Docker image with SSHD, you can log into this Docker container without any issue. It's just like the virtual machine.
And yeah, my second question is like related. So you mentioned there's the TensorBoard support for this. So I'm just wondering, like, because for Yarn, the life cycle of a job ends by the moment like one last container of this job like ends, and we start to scrap everything. Only thing that's persistent in HDFS. But obviously, in the machine learning case, like it's very often you leave the job running overnight. Next morning you check the TensorBoard. So is the lifetime of the TensorBoard tied to the lifetime of the training job, or is it like separate service?
Oh yeah, so this is a good question. So currently, this depends on how you launch the TensorBoard. This is actually very flexible. So in some cases, you can run the TensorFlow with your training job. So the TensorBoard will also terminate it after the job finish. Or you can run a separate TensorBoard service, which will not running. It can run after the job finish or run as you demand.
All right, thank you.
Yeah. So to last minute. So any other questions?
So a couple questions. The first one, like, do you only support Docker, or do you support like OCI for like any kind of like container technologies?
So currently in Yarn, we only support Docker as a container.
Okay.
Runtime.
And the second question is like for machine learning, right? You are running like multiple epochs. So for example, for the first epoch, you are download the data or like streaming the data from HDFS. Then how can you like leverage what we have done for the I/O for the second epoch?
Yeah, so currently we don't handle that. So this depends on how the applications behave. So for example, if they want to download the data for the second epoch, they may need to add this to their TensorFlow job.
Okay. Yeah, because that's like one of the advantage of like Spark RDD, so you can save it into memory. And then another question is like, for example, like it's also related to the second question. So like for example, if you have like one single huge file, right, like storing HDFS, like how can you like split the file into multiple parts and divide them split them into multiple parts and push to each worker?
So I'm not sure if this is a very common case, because my understanding is the deep learning is not I/O intensive for many cases. So if they need, I think we should consider some locality mechanisms, so which we don't support now.
Okay.
Yeah. So yes. So actually the time is up. So if you have any other questions, we can talk offline. Yeah. Thank you.